Alright, now we pick up in this chapter in section 3 on the law of cosines. In the last section we talked about the law of sines. It says on my board here, when solving a triangle, what to do if it's a right triangle, what to do if it's an oblique triangle. Remember, an oblique triangle means there's no right angle. A right triangle, we're going to use the trig ratios. I've wrote down SOHCAHTOA to remind you. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. Of course, the other three are reciprocals. For an oblique triangle, you have one of two avenues to take, and it's all based on what information is given. If you're given two angles in any side, so the angle side or the angle side angle, you want to use the law of sines to help solve the triangle. And if you're given two sides in the non-included angle, this is the ambiguous case, but again we'll use the law of sines if there's even such a triangle that exists. However, if we have two sides in the included angle, or if we know all three sides and none of the angles, we're going to use the law of cosines, which is what I'm going to present next. The proof of the law of cosines is already done for you in the book, and there's the page number, and it has to do with the distance formula, if I'm not mistaken. And it states that if triangle ABC has sides of lengths lowercase letter a, lowercase letter b, and lowercase letter c, opposite vertices, capital A, capital B, and capital C, respectively, then you'll see 6 different possible looking formulas, although these 3 look very similar and these 3 look very similar. It's all kind of based on what side or what angle you're solving for. Now we use these when we have two sides in the included angle, the side angle side, we use these. When we have all 3 sides, then we're going to be looking for an angle and we use these. Now you say, well, that's a lot of formulas to memorize. Well, it's the same formula. This guy right here and this guy right here, all I did was I took this and solved for the cosine of A. And that's what it turns out to be, and I could do the same thing for the others. And these are all the same formulas, it's just that which side is missing. But basically, if you have a side squared, it's equal to one of the other sides squared plus the third side squared minus 2 times the second side times the third side times the cosine of the included angle. So side angle side here, side here, and I have examples of both. So we'll start off when we have side angle side. It says triangle ABC with angle B being 61 degrees. That's supposed to be a degree sign there. It's not a very good one. Let's see if we can do better than that. Yeah, it's a little better. And C is equal to 19 and A is equal to 28. Round the measures of the unknown side and angles to 1 decimal place. So what I'm going to do here, since I have 2 sides in the included angle, now if you don't see that, draw a picture so that you can kind of label things here. Let's have triangle ABC, and we have angle B, and we have side C, and we have side A, and we have side angle side. So I'm going to use this over here to help find the third side, because once I have the third side, then I can use this to find missing angles. And I only have 1 angle, so I'm going to be missing 2 angles here. So in this particular problem, I'm looking for B here. So it's kind of this variation of the law of cosines. B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B. So B squared for this problem would be A squared, 28 squared, plus C squared, which is 19 squared, minus 2 times 28 times 19 times the cosine of the angle 61 degrees. Well, I'm going to definitely need a calculator here. Did I bring my calculator with me? I did. Here we go. I grab my calculator and take 28 squared. First I solve for B squared. 28 squared plus 19 squared minus 2 times 28 times 19 times the cosine of 61 degrees. Now this will give me what B squared is equal to, and once I have that, I'm going to take the square root. Now you have to be careful if you're not using a calculator that does the order of operations for you, because I've had lots of students, they'll square that, they'll multiply these 3 numbers together, but then instead of multiplying these 3 numbers times the angle, the cosine of the angle, they'll add, and then they'll subtract, and then they'll try to multiply, and of course that's not your order of operations. You're not going to get an answer that's going to be proper. So in this case I get B squared to be equal to I have 629.16256, and it keeps on going. So I took it out that many places so that when I use my measure here, if I decide to go ahead and use the measure here for B, well I'll have to, that I can not have to lose accuracy by intermediate rounding. But in this case, B would be approximately, let me raise it real quick to the half power, 25.083113, and it keeps on going here. Again, this is going to be, B is approximately 25.1 to 1 decimal place. I'm going to underline that there. Now, I'm going to find one of the angles. Now, with when you had side-side angle back here, which is now what I would try to do here, use side-side angle, is that you would have an ambiguous case. You might get two answers that look appropriate. But you don't have to use the law of sines here. You can go down to this version of the law of cosines, because now you know all three sides, and you can find an angle that way. So now we already know angle B. If I find, let's say, for example, angle A, then I can easily find angle C, because the three angles adding up to 180 degrees. So now, let's say I'm going to find a cosine here of C. Let me put it over here. The cosine of angle C, which I don't know, is equal to A squared. Now A, remember, is 28 plus B squared. Now I'm going to use this version of it, even though it's going to be a pain to type into my calculator. All those extra buttons, that's brutal, like George Jetson. And then I'm going to subtract C squared, which is 19 squared, over 2 times 28 times the 25.083113. So now, let me figure out what that mess is. So I have 28 squared plus 25.083113 squared, squared somewhere, there it is, minus 19 squared, which is 361, and then I'm going to divide that by the product of 2 times 28, 56, times 25.083113, almost messed that one up right there at the end, and I get the cosine of C is equal to 0.74905, and so on. The reason that this is to our advantage is because when we do the inverse cosine to find out what angle C is, because it's positive, we know it's first quadrant. We don't have to worry about, could it possibly be a second quadrant angle? If it was, it'd be negative. That's one of the big advantages here to using the law of cosines at this step to find the missing angle, as compared to using the law of sines, because you could use the law of sines and you would get the same angle, but you'd probably get two cases. This is the advantage. So now I'm going to hit the inverse cosine, I hope. Inverse cosine of 0.7490544, and that should be enough to give me, oh, did I forget the parenthesis? Yep, I'll try that again. Inverse cosine of 0.7490544, parenthesis, there we get it. And I get 41.491, or into 1 decimal place, I get angle C is 41.5 degrees. And if angle C is 41.5 degrees, and angle B was 61, subtract from 180, and of course, I'm sure you're doing this in your head. I'm doing it the old-fashioned way, just because I get bored sometimes when I don't do arithmetic. And so I find that the answer here for A would be 77.5 degrees. So I have solved my triangle. I know it only lists these three measurements here, but I have the given three. Remember, angle B was 61 degrees, A was 28, and C was 19. And so now I have solved my triangle using the law of cosines, actually using the law of cosines twice. Now, for this guy here, I have all three sides, no angles. I got to find the measure of the angles. Again, nearest tenth of a degree. So I'm going to go to this version right here, and it doesn't matter which angle you want to start with. I'm just going to start with angle A, go alphabetically here, and I'm going to say that the cosine of angle A, it's right here, is the formula, right here. There's A, there's B, there's C, all three sides. The cosine of angle A is equal to B squared plus C squared, so that's 45 squared plus 41 squared, minus A squared right here, minus A squared, minus 62 squared, all over 2 times 45 times 41. So be careful with your arithmetic here, and especially if you're using a calculator, make sure you plug it in properly. So let's see, 45 squared plus 41 squared minus 62 squared per, let's see, divided by, let's see, 2 times 45 times 41, so how about 90 times 41? And if I do that, hopefully I've got it plugged in there so you can see it, and hit that, I will get that the cosine of angle A is negative 0.037398 and so on. So now to find angle A, since it's negative here, I know I'm talking about an obtuse angle in the second quadrant, so inverse cosine of negative 0.037398, I get 92.143. Now let's see if this makes sense. Angle A would be opposite side A, since this is the largest side of the three and pretty good amount bigger. It makes sense that this would be an obtuse angle. That it would be the larger of the the largest of the three angles. So now I have A, and once I have either B or C, I can find the other angle, using the same idea that they have to add up to 180. So you can, again, you could go with a law of sines here and find an angle that way, but I'm just going to go ahead and really do the law of cosines one more time here. Let's just practice it one more time. This time I'll find angle B. So angle B would be A squared plus C squared, so that would be 62 squared plus 41 squared minus 45 squared, all over 2 times 62 times 41. So, back at it. 62 squared. You can see a lot of this is just getting this punched into your calculator, right? I don't think anybody wants to do this all on their own using scratch paper. Divided by, let's see, 2 times 62 would be 124 times 41. And I get this to be that the cosine of B is approximately 0.688434. So now I'll do the inverse cosine, and since it's positive, I know it's going to be an acute angle in the first quadrant. So let's take an inverse cosine of 0.688434, and I get 46.4937, and it keeps on going. So that means for all of our intent and purpose, we're going to the nearest tenth of a degree. That would mean A here would be 92.1 degree. B here would be 46.5 degrees. So if I add those two together and subtract from 180, let's see, I get, I'm going to be extra lazy and do it on my calculator. I get 41.4 here for angle C, 41.4 degrees. to the nearest tenth. These are all approximations here to the nearest tenth. And then of course I have the other measurements. A is 62, B is 45, and C is 41. And as you can see, I have all 6 measurements, and I have solved the triangle. Of course, these 3 were given, but these are the 3 that I figured out using the law of cosines. Very useful to help us solve oblique triangles where we cannot apply the law of sines.